We'd like to welcome Dr. Atsusi Hirumi from the University of Central Florida to our English Language Learning in Immersive Environments event 2021. And the title of his talk is ID Fundamentals, Helping Define the New Normal.
So today I'm going to talk about ID fundamentals and not so much about the emerging technology, because this is the reason that I am typically brought into projects, is to solidify the design that goes with the creation of high-end, immersive, virtual, or even low-end, instructor-led print materials. So this is why I am doing at the College of Medicine and have been doing for 20 to 25 years. I've taken a lot of these materials and I like to think that I put it on steroids and made them richer in some way, so make it more useful. So I hope to show you how these fundamentals, what I think are the key principles that really will help people define the new normal as we return back to whatever the new normal will be. Okay. All right, so with that, we know that immersive environments, as Alicia and others and Randall and Mike have pointed out very nice, gives us all these affordances that other technologies do not. But we also know that technology, while it might increase access, productivity, and affordances, they don't ensure the quality of the educational experience. How many of you remember desktop publishing? Ready, set, go. Some of you, half of you remembered Clippy. So some of you should remember desktop publishing. But if you remember it, a lot of people all of a sudden could produce digital newsletters, posters, flyers, handouts. But the variance in terms of quality really increased, and the quality, overall quality, actually decreased. That's what this wave sign is. That's variance. When you increase quality in industry, you're actually decreasing variance. If you go to McDonald's in one country, you get a Big Mac that tastes pretty much like a Big Mac in another country, because they have what they call high quality, reducing variance around set standards. LMSs, and I'm sure everyone has experienced an LMS now, or 99.9%, right? If you have experienced that, well, again, it increased productivity. All these people went online. How many of you had a bad online teaching or learning experience? Show of hands. Anybody? Anybody have bad experience with an online course? No? Regina, you've always had great online courses that you, I'm sure you teach great online courses, but
her classes are great.
So some of your students and faculty are online, so you don't want to be real, but that's okay. I've seen many terrible online courses, basically page turners that are just so boring that my eyes start just kind of rolling and all this kind of stuff. But again, it's an example of technology increasing access, increasing productivity, but not ensuring the quality of the educational experience. So how can instructional design help ensure the quality of the educational experience? I would suggest that there are three fundamental principles that really help ensure the quality of the educational experience. Instructional design should be systemic, systematic, and grounded in research, theory, and best practices. And that's what I want to focus on today. So what I mean by systemic, we view organizations as a system, a set of interrelated components that have to work together in order to achieve a common purpose. How many times have you seen an organization introduce some new software or hardware? Take, for example, schools in the 1980s, when we came out with the personal computer. They put all these computers in the classroom, but they didn't align the curriculum with it, or the instruction, or the assessment, or even the professional development of teachers. I can't tell you how many workshops I went to where they were teaching software that teachers didn't even have access to. It was like, really? Did anyone have any thought about, what's going on throughout the system? Also see this all the time where the government or the state changes standards, basically the outcomes, right? Curriculum outcome. Do they align everything else to make sure it supports those changes? I remember when I was a doctoral student at Florida State about 30 years ago, I worked for a lot of assistance agencies, and they produced so many cool projects. But as soon as the funding went away, they didn't establish the local infrastructure to support that change. So as soon as the funding went, so did the innovation. So I would argue that instructional design and whatever you do with immersive learning, look at the larger system to ensure whatever you generate is sustained and supported over time. This is also true in a business environment. You may have a corporation that provides certain products and services. Systemic also is related to individual performance. I love to golf. So if you look at golfing as a system, you have a series of inputs. You have a golf course, golf range, golf club, golf ball. You have the golf person swinging. And if you play golf like I do, you typically hit it in the trees and wonder, why am I playing golf so much? But again, just the idea of a system, a set of interrelated components that have to work in order to make learning occur in our case, right? And so this is what's so important about student-centered learning is we rethink about the students before they enter the learning environment rather than treating everyone the same way. But again, systemic. So just to repeat, principle number one, instructional design is systemic. We view individual and organizational performance as a system, set of interrelated components that must work together to achieve a common purpose. To sustain improvements or the implementation of immersive language learning systems, you have to change other parts of the system to sustain that change or align it. Resources must be developed and assimilated to sustain that change. So going to principle number two, it's systematic. So I was a K-12 teacher. I loved K-12. I taught high school biology for years. Loved the kids, did not like the parents, did not like the system, right? But I learned about objectives, I learned about assessments, I learned about instructional strategy, but no one ever put these pieces together for me until I took instructional systems or my graduate work in ed tech and instructional systems design. So what does it mean to be systematic? We have several different systematic design models. People who have taken instructional design courses should be familiar with the waterfall approach to ELLIE. Problematic in some ways, so then we went to more spiral applications of ELLIE, but that was problematic too because they spiraled out of control. Now we have agile design approaches, which is basically ELLIE just represented and done in a different way, but it's all systematic. The outputs of one design task is used to inform subsequent design tasks to ensure alignment between the basic elements of instruction. So I would say this is fundamental to high quality education. Outputs of one task, inputs to preceding tasks to ensure alignment of basic elements. What are the basic elements? I would say all learning experiences need objectives, assessments, and instructional strategy, which includes the presentation and chunking of content. So if you said, what are the elements? I would say these are three elements facilitated in some way by the use of technology. So if you have what I call horizontal alignment, the objectives are aligned to your instructional strategy, which is aligned to assessments. So for example, if I was teaching people how to I don't know, name 50 states for something really elementary, right? What should the assessment ask the student to do? Alicia?
Name 50 states.
Hey, very good. See, she's a great student. Learned a lot from my courses, right? That's really obvious. But does that really actually occur? How many times have you taken an assessment in training or a course that was not aligned to the objectives? You're wondering, where the hell did that come from? How did I get this grade or this grade in this assignment? It's not anywhere near what I've taught or whatever. And your instructional strategy, including the content, should be aligned, right? So I would argue that there are many examples of misalignment in higher ed, more so than in most other places, but in business and industry and K. If there was one thing that I feel like I can do to improve learning across industries, across countries, across sectors, it'd be to ensure what I call vertical as well as horizontal alignment. So what happens? We have intangible objectives. I can't tell you how many times I still see unmeasurable objectives being presented to students, or a laundry list of objectives presented to the students that students just simply ignore. And then when I work with faculty to help them redefine measurable objectives and how they're related, they go, well, why do I want to spend so much time on something I know students ignore? And it's students ignore the objectives because they're not aligned to the objective, to the site assessments, right? So why do I want to pay attention to something that's not helping me distinguish what's nice to know versus need to know? In medical education, that's because I'm been so heavily involved in that right now, we have this tremendous amount of content presented to students. I can't tell. This is why I avoided medical school. It reminded me why I never went to medical school. It's because of how much they have to actually memorize without being aligned to any kind of performance. They take 2 years. Lots of medical schools cover basic sciences for 2 years before they start relating it to clinical practice. Hard to distinguish nice to know versus need to know. So we have an excessive focus on overabundance of content. It assesses acquisition rather than the application of skills, knowledge, and dispositions. And there's also a disconnect between evidence we have in teaching and learning and professional development. We have 200 years of research that suggests that there's different things that you should do to design and deliver instruction based on desired outcomes. How many times have you had a teacher who designed and delivered their course because that's the way they learn? I go to conferences often with exhibit halls, and I ask people, why did you do this? Why did you put this button there? Why did you have this activity? It's like, I don't know, thought it was a good idea. I learned this way, that's because I teach this way. Anyway, common pitfalls. So this is a diagram of the systematic process. You might have seen it from the Dick and Carey model. I use the Dick and Carey textbook when I teach design because I learned from Walt Dick. Very fortunate. There's others out there that are just as good and effective. The idea is as systematic. I've changed some of it for medical education because medical educators, they kind of turn glossy-eyed when they see this because it's unfamiliar to them. So I aligned it with actually evidence-based medicine. So I've tried to translate a lot of the tasks to what they do in terms of evidence-based medicine, because all physicians, 100% of physicians know and apply evidence-based medicine, or say they do anyway, okay? So this is the outputs of one task used as inputs to the next task. You got this iterative process to ensure that everything is aligned. So in terms of assessments in particular, just as an example, you have basically the world of assessment. You have norm reference and criterion reference tests. We don't do norm reference typically in education. Those are the big testing companies that have thousands and thousands of learners out there. They do. So within criterion reference, we have conventional, multiple choice, true, false, fill in the blank. You got performance-based, checklists and assessments, rubrics, and you have holistic and analytic rubrics. So when I teach people how to align assessments, for example, I go over these different types. We talk about outcomes. So this is a chart that I've created to compare different taxonomies of learning outcomes. So if you're familiar with a traditional tripartite approach, it says there's a cognitive domain, affective domain, and the psychomotor domain. You might have heard of Bob Gagne and his work with the conditions of learning. Most of you have probably heard of Bloom's taxonomy. I like the revised Bloom's taxonomy by Anderson and Krathwohl that says there's 2 dimensions, right? You could remember facts, remember concepts, remember procedures, remember metacognitive knowledge, understand them, apply them, analyze each of these types, and create. And that's what I love about this taxonomy. It's one of the few that refer to creating products and things. Okay. So with this, I suggest that as general guidelines, conventional multiple choice true false questions are really good and efficient for assessing the acquisition of verbal information and concepts where there's one correct answer or one way of deriving the answer. Performance and product checklist, very good for rules. Application, where again, you have one correct way of doing things or one correct answer. But when you start getting to higher order thinking and more complex, ill-defined domain, that's where I recommend using more kind of assessment rubrics, which give you more of a general criteria for achieving or demonstrating competency. But again, I don't want to give you a lot of details at this point. If you're interested, this is the table. Alicia, you should remember this. You've done this in the course, right? I still do it. This is how I get my designers to align their assessments. They complete this table. They've defined skills from a cognitive task analysis. They take those skills, translate them into objectives. They classify those objectives into domains. They then specify the type of assessment, conventional criterion reference, checklists, rubrics. Then they create the item, and then you could check to see if the behavior required to complete the assessment is aligned to the behavior in the objective. And if you look at my number 1 handout, I have an example of a alignment table, and then the resulting instruments that were produced based on generating the table. So again, this is just a handout that I've included with these materials just to help you if you're interested in this process. So going back now to hopefully, yep, good, we're still here. How do you align the instructional strategy? Very similar. Okay? If I have one correct answer or one way of deriving the answer or demonstrating the performance, teacher-directed, self-directed learning can be an appropriate strategy. It's effective, efficient. If I'm teaching someone how to use a photocopy machine, do I really need social constructivist approaches to learning? Maybe not, right? If I'm teaching a medical doctor how to do brain surgery, do I want him or her to construct their own way of doing it? I would say definitely not in that case. But if I want those doctors to come up with new solutions, new vaccines, new ways of improving health, then that learner-centered approach might be more appropriate. So for this, I have a couple other handouts. about comparing teacher-directed to learner-centered methods. I have this handout included in my materials that compare both approaches in more detail. If you're interested. Okay, I'll let you check them out in more detail. I also have, this is one of the handouts that I'm most frequently asked to provide or go through. I've compiled all these different instructional strategies that have been published over time. These are constructivist, learner-centered approaches, experiential learning strategies. Some of you might have heard of Cobb and his experiential learning cycle. I love learning by doing because it does take into account a lot of stuff that Mike was talking about, stories, right? Present a story, backstory, roles, and role playing, that kind of stuff. You probably heard of problem-based learning. Problem solving, David Jonasson, who's one of the leaders in our field, unfortunately passed away a little while ago with brain cancer, but again, did a lot of work with problem solving, different strategies based on different types of problem solving. Good. Experiential learning. I love this 5E model. I use this when I teach cognitive neuroscience. I present something in the beginning, a video, a thought-provoking question, a really interesting image just to engage people. Then I let them explore different resources based on their technical expertise. So cognitive neuroscience, a lot of technical information. I have a graduate level neuroscience textbook, but I also have YouTube videos that are for people with no biology. What they have to do is explain what they learned using demonstrating critical thinking. So I have this criteria that's been published about critical thinking. And so they have to explain what they learned, then they elaborate on it by redesigning a course based on what they learned, and then I evaluate their work. Simulation models, constructivist models, a lot of stuff. You might have heard of Gagne's 9 events, much more teacher-directed. I have some neurobiological approaches, including my own strategy that I've been developing over time called interplay. And if you'd like to learn more about that, I'll send you some resources there. Probably heard of brain-based learning. Okay, so there's some more resources for you. All right, so getting back to this, those were the comparisons. Those were the grounded strategies for applying either teacher-directed or learner-centered. Getting to the last principle that I want to cover. I see most people are still engaged that have videos. That's good. Okay. Although I did see Regina yawning a couple times. That's okay. You can have coffee. That's all right. You're still good. So what do we mean by grounded? Hanifin and his colleagues, Susan Land, his wife, suggests that grounded is a systematic implementation of processes and procedures that are rooted in established theories, research on human learning. So here are 5 conditions, and all my students, if you remember, Alicia, have to demonstrate that they have to be able to defend their designs. So which theory, what research, what documented best practice did they use, and how did they implement them in their designs? Consistent with research finding, generalizable beyond conditions, validated, and based on desired outcomes. Why is that significant? It aligns theory, research, and practice, helps you explain and predict results, allows for the continuous improvement, and provides a pedagogical foundation for your design. So there's a lot of instruction in the world that's not grounded that works, right? But I would suggest that the subject matter expert who created that instruction has to teach it in order to be effective. Because the subject matter expert fills in lots of gaps in their design as they teach the materials. So any K-12 teachers here? Do I have any K-12 teachers? No, they're all higher. Well, I remember when I was in K-12, substitute teachers would come in and they would never be able to teach the class based on the lesson plans created by the teacher, because the teacher would fill in, again, lots of gaps. So the power of systematic design is if you use these approaches, you come out with instruction that's general. You could use it in different places as long as you have qualified people. So I've modified Dick and Carey's model to show you how you could appraise and acquire evidence and apply evidence through different design requirements. Let me show you how I do that. So you have findings from step 1 and 2, which is your goal analysis, subordinate skills analysis, learner and context analysis, if you're familiar with systematic design. But then this is where I'm helping medical educators. So clinicians have basically one database to query about how to do the best diagnostics, the best tests, the appropriate treatments. They have what's called a Cochrane database. And when a clinician experiences some disorders, they could query that database and come up with the evidence necessary to come up with the right treatments or the right management plan for a patient, for example. Well, how about education? We've got lots and lots of research about lots and lots of different things. How do you find the evidence that supports your design? I would argue that there's 3 fundamental domains that you should look at. One is research on your desired outcome. So what's your desired outcome? Randall, tell me about one design project and what you were trying to teach.
Well, you know, one that I'm using with my students right now is using a tool called Twine to create interactive fiction that they could use in the language classroom. So in this case, they're focusing on vocabulary elements that they want to integrate in their story that would connect to a textbook that they might be using to reinforce the vocabulary.
Okay, so you're teaching them vocabulary.
Right.
Okay. So I would encourage the instructor and designers to look at research on learning vocabulary. And what does that research say? Then I'd also have them look at their learning, educational philosophy. What are your beliefs about how and why people learn? And then what's your instructional approach? You're using game design, right? So what does research say about game design? And then you take a look at these studies and papers. You can assess the quality of that evidence if you want to, but then you come up with principles and strategies or requirements that guide the design of your assessments, your strategy, and your materials. You can also take a shortcut. So here is a set of principles. Here's another handout that I put together. So I've synthesized principles that have been published about behavioral, based on behavioral learning theories, based on cognitive information theories, cognitive constructivist principles, as well as neurobiological. So if you look at these, and you also see I've defined what I call multidisciplinary design principles. How many of you have heard of learning sciences or the science of learning? Can I have a show of hands? Anyone heard of the term learning sciences, science of learning? Some of you? Maybe I should get everyone to stand up so everyone's moving a little bit, right? So it helps. No, stand. There you go. Good. So some of you might have heard about the science of learning, the learning sciences. That's kind of the current trend out there. And it's a multidiscipline. They're basically saying many people have studied learning from many different approaches. scientists, cognitive neuroscientists, educators, philosophers, engineers, even, people from different disciplines. So we need to synthesize what we know and combine them in one set of principles. So here's some examples. They're behavioral learning principles. This is cognitive information processing. Here's one from multimedia learning theory. Some of you might be familiar with Richard Mayer's work. Right, their principles. Evidence-based micro-learning strategies. You're teaching verbal information. These are the recommended tools and techniques. If you're teaching people concepts, you should consider these tools. And all research, there's basically empirical research suggests that these techniques help people learn concepts. These techniques help people learn rules. These techniques help people problem solve, et cetera, et cetera. I've got many out here. I love these. I use these all the time. So I'm an experiential learning theorist. So how many of you have kids? Any of you have kids? Some of you have kids? So if you have kids, you can lecture to them as long as you want, but they're going to keep putting their hands on the fire until they get burned. So I used to teach people all these different learning theories and all that and I still do, but I have become an experiential learning theorist because I believe people learn best from real life experiences. So all my designs are based on experiential learning principles, such as these. But again, I've compiled all these lists of principles. Let me go to some of the, you might have heard of brain-based learning. Let's see, something, brain rules. Oh, here's David Merrill's work on the first principles of design. So if you're in instructional design, you might have heard of David Merrill, or you should have heard of David Merrill. Everyone should nod their head. I've heard of David Merrill if you're in instructional design, okay? He suggests that no matter what type of learning or learning context, you should follow these 5 principles. And then here's some science of learning principles. But again, I'll let you go over this as you want to. Okay. So here's another document that shows you some of the research. Here's some examples. Domain 1, learning outcomes. Learning a procedure, this is what you should do. Different learning theories. Okay, here's some sample outcomes. Different strategies, delivery method. So basically, I've given you references to illustrate the type of research you want to look at if you're looking into these domains. All right, so let me continue. So this is my evolution of learning theories. If you read any kind of learning theory book, you'll find classes of learning theories. Some approach it a little bit different. Some put humanist out here. Social, I put social under constructivism, that kind of stuff. But in general, I classify it along these 5 areas. So principle number 3 is instructional design should be grounded based on research theory and documented best practice. That's basically what we currently call evidence-based design or evidence-based education. You might have heard that as some popular terms being thrown around now, especially if you're into STEM education. STEM education is all about what's the evidence. So here's some more evidence stuff, okay? So in summary, how can an ID help define the new normal? I would suggest that technology can increase productivity, access, and affordances, but they may also increase variance, thereby reducing the quality of the educational experience. To help ensure quality, we need experts like Randall and Mike and Alicia to help us with our designs, but I would also suggest that you should follow these 3 principles. Principle 1, design is systemic, components working together to achieve a common goal. It's systematic, outputs used as inputs to ensure the horizontal alignment of objectives, strategies, and assessments, and well as grounded in research, theory, and practice to ensure the vertical alignment of your designs to the research and theory. So with that, I will entertain any questions or comments.
So much as a comment that, yeah, these materials are absolutely amazing. And I can see applying them across so many different courses because, you know, most of the students I work with are future ESL teachers or other languages. And this applies to, well, any field, right? It applies to any field in really wonderful ways. So I look forward to getting my hands on it.
No,
That's okay, Randall. I look forward to picking your brain as well. So.
Whatever's left.
I had a question about instructional design and the way that and thank you for your presentation. That was an amazing set of resources, as Randall just said. But are things mostly then framed in terms of the designer's ideas of how learning takes place and the designer's idea of how things, or do we have a lot of research also from not what succeeds for the learner, but the learner's idea of what it means to be taught and to receive and to produce based on that?
This systematic process is the analysis. So one of the analysis is your learner analysis. So in your learner analysis, you're accessing and querying the learners and finding out what their needs and interests are. But one thing that I try to encourage people is not to get into this literature on learning styles. So we have basically debunked learning styles. People do not have learning styles, okay? People develop learning preferences. If you don't like to read, guess what? You like pictures. Whoa. But you know what? Everyone learns better through pictures. The visual sense, your visual sense, and I think it was Randall or Mike or both of them talked about different sensory learning. I agree that we want to evoke as many senses as possible, but the strongest, most powerful sense we have through science is our visual sense. That's why YouTube is so popular. We get to see things being done. That's why the demonstration principle is so important in Merrill's work. I'm creating animations of all my assignments in all my classes that demonstrate, illustrate how do you complete these things because of the visuals. So I agree, Shobana, is that how you pronounce your name? We have to learn from learners. I mean, I could design as much as I want based on all my experience whenever I test it with learners, and that's what I would recommend. Is testing with learners. And anyone who's in game design, I think Randall and Mike would profess, you have to play test. Because what I think is fun and engaging is not typically what my audience thinks is fun and engaging. So play testing is critical. So that's where I get a lot of my input from my learners, is I do a lot of testing early and make a lot of mistakes early to come up with the right solution as fast as I can. So I would say 2 areas, right? The learner analysis and the formative evaluation is where we take into account the learner's perspective. And also when I work with educators, I go through their educational philosophy with them if they're interested. So what are their values and beliefs? Because that's important to take into account.